right, I'm going to go over how we find the sums of arithmetic series. So for this first one, we want to find the sum of the first 15 terms. That's what this S sub 15 means. And we're given that the sequence is 5, 9, 13, 17, and so forth. So for this, we're going to refer to the wonderful, useful summation formula, where we say the sum of the first n terms for an arithmetic series is going to be n times a1 plus an all over 2. In my lesson video, I go over why this formula works, but for now, let's just, we're just going to use it. And let's just, go with it. So here we want to find S15. So we're going to have our n be 15. So we're going to have S15 be equal to 15 times a1 plus a15 over 2. So we need to find a1 and a15 for this to work. A1 is just going to be 5, because that's the first term. A15 is what we have to find. We don't have that yet, so we're going to leave that as is. And let me kind of put this in a red box so it doesn't get confusing. Okay, so then we need to find A15. For this, we can, use our other equation for the anth term, where an equals am plus d times n minus m. Dun, 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 dun. So in A15, AM could be anything. Let's just make it A1. We'll say A15 equals A1 plus D. The common difference D is what the sequence is increasing by or changing by. And that's going to be 4 because it goes up by 4 each time. So D is going to be 4. And then N is our 15. And M is 1. Now, again, I can make M anything. I can make M. I can make AM or AM. I could pick A2, A3, A4. A1 is usually the easiest to work with because, 1 is a simple number to work with. So then we just evaluate this. So then A15 is going to be A1, which is 5, plus 4 times 14, or 5 plus 4, what is that, 56, which will be 61. And so 61 is going to go in here. And then we just evaluate this guy. Let's go around. And we'll get S15 is 15 times 66 over 2. And you could go 7.5 times 66, 15 times 66. But well, I want to get my calculator. I don't want my calculator to get bored, so I'm going to let it, participate in this problem. So we'll get 990 over 2. And we'll get 495. Right, sweet. Let's do another one. Let's look at the next one. It's gonna have a summation notation. So I'm gonna erase this. Don't worry. That's why you have a video where you can rewind. And we're going to do problem B. Keep our formulas up. Let's see, B has, whoa. Here we got series. Okay, is 1 to 12. All right, these ones are actually really easy. It's just a matter if you know how to read this notation. So this is saying to find the sum of the first 12 terms, or the terms from A1 all the way to A12. So we want to find the sum of A1 plus all the way to A12, because that's what the 12 is. And this is actually really easy because we can just find A1 and A12 directly, because we can just plug it into this equation here and then use this. So we're going to use this. So let me set that up first. Let's go. So S12 will be equal to 12, because that's our n, times A1 plus A12 all over 2. And so let's go find A1, and we just got to plug 1 into here. So A1 will be -2 plus 6 times 1, which will be -2 plus 6, which will be 4. And A12, we just plug 12 into here. -2 plus 6 times 12. -2 plus 72. And that'll be, well, let me just write it down in case you need the work. 70. So then we throw these into our equation here. So we'll have 12 times 4 plus 70. All over 2. Let's wrap this around. And we'll get S12 equals 12 times 74 over 2, or 6 times 74. And that I think it's 444. Let me give my calculator a workout here. Yeah, we'll get 444. We'll get 888 over 444. Or 888 over 2, which is 444. All right, so there you go. Hope that helps.